Hello students, welcome to Stuti Academy. I am Poonam Sharma, your science teacher. Welcome you all another session of science of class 9. I hope you all are fine and in pink of your health. So students, in previous class I have started chapter number 1, matter in our surroundings chapter, which is chapter number 1 of chemistry. I'll just check my connection. I think there is some problem. Just a second. I hope I am audible. Okay. So students, in previous class I have started with chapter number 1 of chemistry, which is matter in our surroundings. Okay. So first I'll do recapitulation of the topics which I have covered in previous class, so that it is easy for you to understand the concept clearly. And if you have any query related to the previous topic, you can write in the chat box. So in previous class I explained about matter, what is matter, what are its properties, and what does it contains. What are the things which make the matter? So if we define matter, matter is that substance which occupies some space and has some mass. So this is a definition of matter. And this matter is made up of very tiny particles called atoms. And we will study about these particles in detail in forthcoming chapters. The particles which are present in matter, they are moving randomly. They follow zigzag path, and this zigzag path of particles of matter which follow the zigzag path. This kind of movement is known as Brownian movement, which I have already explained in previous class. So these are the few characteristics of matter. In this chapter we'll study about only physical properties of the matter, and if we study the chemical properties, we'll study in chapter number 2. And what kind of questions come in exam on the basis of this topic, this also I have discussed with you yesterday. Like, why is light not considered matter? Matter is that substance which occupies space and has some mass. But if we talk about light, we can see the light. Only we can see the light. It does not occupy any space. That's why it does not come under the category of matter. And if the definition of matter comes, then you need to write anything that has mass and occupies space is called matter. Now, what are the different states of matter? There are mainly 3 different states: solids, liquids, and gases. Okay. Now, yes, if you have any query, you can write in the chat box. There are three different states of matter: solids, liquids and gases. If we talk about solid state, due to the tightly packed arrangement of particles in solid, as you can see here, very less intermolecular spaces are present. And due to these less intermolecular spaces, they have a very strong bond of attraction between them. So if we talk about solids, they have less intermolecular forces. They have strong intermolecular forces in very less intermolecular spaces. I am correcting again. In solids, due to the tightly packed arrangement of particles, they have strong intermolecular forces and they have definite shape, or we call them, they are rigid in structure, and they have a definite volume also. Due to this arrangement of particles, students, they have high density, high melting and boiling point, because they need high temperature to break that force of attraction between them. And solids cannot be compressed. Solids cannot flow also. So these properties I have already discussed with you. If we come to liquid part, this is the most important part of this chapter. If we talk about liquids, they have very weak intermolecular forces, large intermolecular spaces. They do not have any definite shape but they have definite volume. Here the one word comes: volume. This volume is the space taken up by the substance. Volume is defined as the space taken up by a substance is known as volume. So liquids have definite volume, but they do not have definite shape, and they have very low density, low melting and boiling point also. Liquids cannot be compressed. Here I am correcting again. It cannot be compressed, but liquids can flow. If you see the arrangement of particles, the particles are quite very far away from each other. They have so much of space between them, as a result of which they have weak intermolecular forces. Now come to the next state, that is gases. If we talk about gases, they have very weak intermolecular force, very large intermolecular spaces. As you can see in this diagram, the particles are very far away from each other. They do not have definite shape and volume. Density is very low. Gases are highly compressible and they can easily flow. If you remember, yesterday I told you about one process, that is diffusion. Diffusion is a process with the help of which the particles can move from higher to lower concentration. And in gases, if you remember, I gave one example. When your mother is preparing food for you, the aroma of the food can easily reach to the other corner of the house. Same when you use perfume, the aroma, the fragrance of that perfume can easily reach to the other person who is standing just at some distance to you. So this process is due to the diffusion. Now, apart from these three main states, two more states are there, which is plasma and Bose-Einstein condensate. These two are the other states of matter. If we talk about plasma, in plasma state, the particles are highly energized. They are super excited. For example, the particles which are present in LED bulbs and tubes, they are the example of plasma. And if we talk about Bose-Einstein condensate, and this Bose-Einstein condensate state was discovered by Satyendranath Bose and Albert Einstein. And in this state, the gases are very cool at a very low density and at a very low temperature. So these are the two more states apart from solids, liquids and gases. And this question I have already discussed with you. When you prick a pin in an inflated balloon, then what happens and which process is responsible for it? So the balloon bursts and the process responsible for this is diffusion. And question can come on the Bose-Einstein condensate also. So in this you have to write down the definition of Bose-Einstein condensate, which I have already explained to you. And the next question is, why are gases compressible but not liquids? It is due to the intermolecular spaces. Intermolecular spaces are more in gases in comparison with the liquids. So this part we have done yesterday, and I just did recapitulation of the topic so that it is easy for you to understand the further topic. I am talking about matter again and again, which exist in different states: solids, liquids and gases. So these three states are interchangeable, which means they can easily convert from one state to another state. And the example of this kind of interconversion of states of matter is when you take an ice. Just keep that ice at room temperature and you will observe that ice starts melting. And when it melts, after a certain span of time, you'll observe that liquid is also not there. So first, that ice changes into liquid form, and then that liquid form changes into gaseous form. So it means matter, the states of matter can easily convert, changes from one form to another form. Now the question arises, how these changes takes place, or how this interconversion of states of matter takes place. And the main factor which is responsible for this is temperature. Here you can see solid changes into this liquid, and liquid again, if we continue with the heat, it changes into gases. But if we decrease the temperature, in this case we are increasing the temperature if we increase very close to each other. But if I provide heat to this, then this space starts creating, due to this heat, these particles starts gaining kinetic energy, and when they gain kinetic energy, they start vibrating. And once they start vibrating, they start moving apart. They start moving apart, and as you can see here, spaces are creating between them. So in this manner, these spaces are creating between the particles. Now after this, if the spaces are there, then this solid changes into liquid form. And if we apply same formula, it means if we are giving heat to liquid in which the particles are there, as you can see, these are the particles of a liquid, and when we are providing heat to it, I am providing heat to this, then same happens here also. Now the particles start gaining kinetic energy again, they start vibrating, and once they start vibrating, they start moving apart, which results in creating space between the particles. and as a result the liquid changes into gaseous form. So in this manner, if we increase the temperature, solid changes into liquid and liquid changes into gases. But sometimes if we decrease the temperature in this manner, then they start losing kinetic energy. If we increase, they start gaining kinetic energy, and if we decrease the temperature, they start losing kinetic energy. And when they lose the kinetic energy, then the particles start coming closer with each other, which results in the change of the state again. But here this time, this gases changes into liquid and liquid changes into solid. So it means the effect of temperature is responsible for changing the states of matter. Whether we are increasing the temperature or decreasing the temperature, in both the cases there is a change of the state of matter, because the particle starts gaining kinetic energy in case of increasing temperature, and they start vibrating, which results in creating the space between the particles. On the contrary, if we reduce or decrease the temperature, then these particles start giving kinetic energy, releasing. As a result, they start coming closer with each other, which results in the change of state. Now, what type of question can come on this topic? Like, why do solids expand a bit on heating and contract a bit on cooling? And the answer is, these solid molecules do not have sufficient intermolecular spaces. As I told you, the particles in the solid state, they are very closely packed together. As you can see here, I just draw properly. Yes, as you can see here, see, in solid, the particles are very close to each other. They have very less intermolecular spaces. So thus it expands a bit on heating. It means when we provide heat, it will take more energy. It requires more energy to overcome that forces of attraction. That's the reason why they expand a bit on heating. The interparticular forces of attraction are very strong because they are so closely packed. So they do not allow these solid particles to move from their main position. So they start coming again. That's why they cool a bit on contracts. So now, children, when we reduce the temperature, some solids expands on heating and some solids contracts. For example, iron, when you heat it, so it contracts. So that's an example. When you provide heat, so it contracts. This is the reason. Now the second question is, draw a diagram to show interconversion among states of matter. So this diagram you need to draw, and in this you have to depict all the states of matter: solid, liquid and gases. As I told you, when the solid changes into liquid and then liquid changes into gases, or gases changes into solid, so these arrows shows the direction. So this diagram you can draw when the question comes, show the interconversion among states of matter. If you have any query, you can ask. Just write in the chat box. I hope till here this topic is clear to you. Now next is melting point. As I told you, solid melts. So the temperature at which the solid melts to become a liquid at atmospheric pressure. I think yes, now I think it's fine. I was explaining about melting and boiling point. And what type of question can come from this topic? That's it. That is boiling point. Define boiling. Why is boiling considered as bulk phenomena? As I told you, it is known as bulk phenomena because when we provide heat to liquid, the maximum number of molecules or particles of liquid, they start gaining kinetic energy from the surface of a liquid. So that's the reason we call boiling as a bulk phenomena. So I hope till here this topic is clear to everyone. Due to some network issue, some problem was there. So I'll just repeat this topic again. Melting point, the temperature at which solid melts and changes into liquid form at atmospheric pressure is known as its melting point. The melting point of that particular solid. And boiling point, the temperature at which liquid boils and changes into gaseous form at atmospheric pressure is known as its boiling point. And boiling point is known as bulk phenomena because when we provide heat to the particles of liquid, the maximum amount of the particles from the surface of the liquid starts gaining energy and they convert into gaseous form. So that's the reason boiling point is known as bulk phenomena. And what kind of questions can be asked in exam? Define boiling. In this question, you just need to write down the definition of boiling and why is boiling considered as bulk phenomena. So why is considered as bulk phenomena? As I told you, when we provide heat to a liquid, the particles are converted into vapors form and maximum number of particles from the surface of the liquid starts gaining energy and they convert into vapor form. That's why it's known as bulk phenomena. Next is latent heat of fusion and latent heat of vaporization. Before latent heat of fusion and vaporization, I'll tell you what is latent heat. Latent heat. See, latent heat is a kind of a heat, or we call it as a hidden heat, because this heat is used to convert the states of matter, but it will not increase any temperature. So latent heat is a heat, or we call it a hidden heat. So there are two types of latent heat. Latent heat of fusion and latent heat of vaporization. Suppose we have this beaker. In this beaker, I'll add some ice, which is solid state of matter, and in which the particles, as usual, they are closely packed. And here I'll place one thermometer. This is thermometer. Okay, so this thermometer reads the temperature of the ice, which is 0 degrees Celsius, which is, just a second, yes, which is 0 degrees Celsius. And when we provide heat to this beaker in which we have placed some ice, so after certain period of the time, we'll observe that the reading in the thermometer remains 0 degrees Celsius only. It will not change, although we keep this ice in a beaker, and still it is showing 0 degrees Celsius. And if the complete ice changes into liquid, so when it completely changes into liquid form, then only just a second, yes, when it changes into liquid form, then it only there is a rise in the temperature in the thermometer. So here, and this heat which is used to convert the state of matter, the solid melts into liquid, this heat is known as latent heat. Although we are providing heat continuously, we are providing heat to this beaker, and ice is changing into liquid, but the temperature in the thermometer, it is still showing 0 degrees Celsius, and it only increases when the entire solid changes into liquid. Then only we'll observe some rise in the temperature in the thermometer. So this kind of heat, which is used to overcome the forces of attraction between the particles of a state of matter, is known as latent heat. It will not increase the temperature. Here you can see there is no increase in the temperature, because in thermometer the reading as it is, it's 0 degrees Celsius only. So I think this topic is clear to you. So this is about latent heat. Thank you, students. Thank you for giving your valuable time. And if you have your query, I'll definitely take in next class also. You're most welcome. You can ask any question, whatever the topic I have covered so far. Thank you everyone, and have a nice day.